Without further delay, I'd like to introduce today's presenter, Michelle Bustamante, Chief Architect for iDesign Inc. Michelle, you now have the floor.
Thanks very much, Sarah, and welcome everybody. So here we are again talking about WCF, and this is a 15-part series. This will be part 4 of 15. And what I'm going to be talking about today is exceptions and faults. So we're going to discuss error handling in detail. And just before we get started, I'll introduce myself, give you a bit of background. So my name is Michelle LaRue Bustamante, and I'm an architect with iDesign. Do architecture consulting on mostly the .NET 3.0 stack at this point. And I'm a regional director for Microsoft in San Diego. And the thing that you want to note about this slide is that I have 2 weblogs. One is dasblonde.net. That's where you'll find I post various entries on sessions I do related to WCF and other things like CardSpace. And that indigogirl.com, that's where you can get all of the book code. So I just finished a book on WCF called Learning WCF, and all of my code is posted there. So you can go to that site to get everything that I've shown you today, for example. Before we get started, let's just talk a little bit about what I'm going to go through. So we're going to start with exception handling for WCF, and just what is the default behavior when you build a service, host a service, consume a service, without you making any changes. What is the default? And that way you can understand what are the things you should be thinking about when you deploy services in terms of making sure that you address error handling. So one of the things we'll talk about is how we propagate exception details to clients that call your services. We're going to talk about how you throw and catch faults, meaning SOAP faults, which is the standard way where exceptions are serialized for your services. And then we're going to talk about how you can deal with uncaught exceptions and maybe some centralized ways that you can handle that and make sure administrators are notified, for example. So the prerequisites for today are just that you have experience building Microsoft.NET Framework applications, so you understand assemblies and so forth. And then, of course, a basic understanding of WCF will help you in terms of how to build a service, expose an endpoint, consume a service, generate a proxy. All of those types of things will help you. If you haven't had experience with that, you can still listen in, but remember that we've done already 3 other webcasts in this series that you can go back and visit. And if you go to my weblog, you'll find a link to the entire series where you can go and replay some of those webcasts. So, starting with our agenda, let's start by talking about SOAP faults. So, when you throw exceptions from your assemblies in your application, typically what an exception will do is actually propagate all the way up to the runtime if it goes uncaught. So for example, if you're running a Windows application, what will happen is your exceptions will flow all the way up to whatever that main thread is, and it will kill the Windows application ultimately. And when we deal with services, things happen a little bit differently. So for example, ASP.NET, if you were hosting web services there, or in WCF, same idea. We get a unique thread for every request that comes in, and only that thread will actually be terminated if there's a problem. So the exception will flow all the way up to the runtime, and the runtime will kill that thread. So in other words, we're not going to crash down the ASP.NET Worker process if we're bringing hosting services in IIS, and we're not going to bring down the Windows service if we're hosting services there. We're just going to bring down that particular request thread. And that causes other problems too, which we'll talk about when I get into the WCF side. The point is that uncaught exceptions, when they reach the service channel, they actually get converted to SOAP faults, just like they would with ASMX ASP.NET Web Services, because they have to be serialized into some format that can be understood then by the calling client. And since web services are interoperable, typically when we're exposing our services on HTTP, then we'll get an XML SOAP fault, which is a standard for how exceptions can be serialized in a web service environment. Now, WCF is not just for web services, so when you're using TCP, then of course the same type of fault is serialized, but it's done in a more compact binary mode that's proprietary. So it's really still the same representation at runtime in either case. So what happens is all exceptions are serialized to SOAP faults, and there's two formats for a SOAP fault. There's the original SOAP spec, SOAP 1.1, and then there's SOAP 1.2. And really the differences between these are subtle, primarily in just what the XML nodes are named. And you shouldn't really have to worry about that because it should automatically happen for you when you are hosting your services over one of those two protocols. So here's an example of a SOAP 1.1 fault. You can see here that it says there is a fault inside the body of the message, and then there's a fault code of client, meaning the client caused the problem. We like to blame the client by default, actually, when you generate a fault. And then here it says that the message is invalid operation has occurred. So obviously an exception was converted to a fault, and that was the basic details we have to provide. Now, in the case of SOAP 1.2, you're going to see additional details because, for example, usually we have addressing headers like this one here for action, and that says that the action is SOAP fault. And furthermore, some of the naming conventions have changed. So, for example, code has a subcode value, for example, that you can create. And in this case, we just have a value of sender. Notice it was changed from client to sender. The specification has reworked or refactored some of the naming conventions in SOAP 1.2. Again, you shouldn't have to worry about these things, but it's interesting for you to know that when you're doing interoperable web services with WCF, that the choice of SOAP specification that you use when you host your services, the choice of protocol, will govern how even a fault is serialized. You'll also see a reason here instead of just a string, and this allows you to have multiple reasons with different languages in case the client needs it represented in a different language. So you can send more than one, for example. Okay, so that's a SOAP spec detail. The point is that there are these SOAP fault elements. There's these pieces of information that go into a SOAP fault, which is the way we serialize exceptions between clients and services. There is primarily a code, which you've seen is client or service and or sender receiver, for example. And then you can have custom codes that you create. And then there's reason, which is really the main description. And then there's a couple of additional things, the main thing being the details section. That's where you can put a whole blob of XML that is really additional information that a client might need about the problem. And we'll talk more about that when I show you an example. And then we've got some other things like role and node. These are more advanced because typically you shouldn't have to change that. Those are really for folks that are building things like intermediaries and so forth. So for the most part, you'll leave those alone. And again, all of this detail is done automatically for you by WCF, so I'm just giving you some background on what is a SOAP fault so that when we're talking about it, it'll make sense to you. So let's continue and talk about WCF. So an uncaught exception will possibly be thrown by, say, the data access layer or the business layer, and then your services are calling down to those layers. So if those exceptions are propagated up to the service has a choice to make, whether it's going to catch the exception and handle it and maybe throw a fault, or whether it's going to just allow the exception to happen. So by default, of course, if you don't catch all kinds of exceptions that are thrown by your business layer, and you just let those flow up to the runtime, then what happens is WCF converts that to a general SOAP fault. And actually, the default behavior is that the exception that was originally thrown is not shared with the client. And the reason for that is for security reasons. You don't really want your SQL exceptions that show information about the incorrectly formatted statement or connection string to go back to the client, right? So those pieces of information, you have to opt in what you share with your clients. So by default, consider this exception. We have an invalid operation exception being thrown that the method is not yet implemented. If that goes uncaught at the service tier, then the service model, WCF, will return a SOAP fault. And again, there will not be any details about what originally happened. In fact, not even the type of exception is shared with the client by default. And then the format, whether it's SOAP 1.1 or SOAP 1.2, depends on the binding. So if you're using basic HTTP binding, it's going to be SOAP 1.1. All the other bindings are SOAP 1.2. Here's an example of what that fault might actually look like. So we've got a fault with a code, and that code, again, this is generated by WCF. So what's going to happen is they've created a custom code called internal service faults, and then they've provided a fault string which says the server is unavailable or unable to process the request, but notice it says nothing specific about the details of the problem. The same thing goes for SOAP 1.2, except that we've got additional or different format. So receiver was the fault, internal service problem, and then the server's unable, same error message, which goes inside the reason text. And so the point here is that this is an error you've probably seen before if you've played with WCF and thrown an exception. And that's the generic result if you don't opt in to sharing exception details. So when you're debugging, of course, it can be a problem if you can't see the information about the problem that happened at the server, and then you have to turn on the trace logs and look at the trace logs, which could be useful anyways, but it might be helpful for debugging purposes to turn on the ability to share all the details of the stack trace and the problem at the server. So what you can do is you can turn on the setting or debugging behavior, setting the include exception details in false to true, which defaults to false. And so if you enable this, what happens is the details, including the stack trace, are actually flowed to the client. So clearly, because there's a stack trace, we don't want to do this in a production environment. How you enable this is you provide a service debug behavior, and that can be done declaratively with a service debug section as shown here. So what you've got is a service with an associated behavior configuration called service behavior. And that means that all the endpoints inside this service configuration will use this behavior here, which has service debug set to include exception detail in false to true. And so this, again, by default is off. If you want to actually enable this in the service itself, you can do it declaratively in a service behavior attribute. The problem with this, of course, is that that hard codes the service to enable this. So you probably wouldn't want to do this, generally speaking, because this would tie your service and the code to the mechanism in which you share exception details. So although this is possible, I wouldn't recommend it. Now let's take a look at an example of this. So I'm going to go ahead and show just a quick demonstration of dealing with exceptions and a couple things you might care about here. So I'm going to share my desktop, and I'm opening up a solution called Exceptions Demo, and what this has here is a service called Exception Service, and you can see two operations, throw exception and throw exception one way, and I just want to compare how the two behave. And you're seeing that there's a service behavior set right now to include exception details in false. That's actually the default, so it's as good as not having that there at all. And I'm going to expand this so you can see that I'm throwing an exception from both operations, not implemented exception, just to see what happens. Now let's take a look at the host. So the service host has a configuration, and that configuration, which defines the endpoint that we're going to be reaching. As soon as this opens up here, it's just loading up the app config file here. So, okay, here we go. So what we have here is a service with the behavior, and you'll notice I'm exposing basic HTTP binding at the moment, okay? And I have include exception details in false set to false, which is the default behavior. Okay? Now, a couple things that I want to show you. So first of all, I will just run this as it is. So I'm going to recompile the solution. And when we run it, we're going to see the first example of the SOAP fault, if you will, which is the nondescript error that says that it's an internal server problem. So I'm going to go ahead and run this now. And it's just a console application, so the client's going to call throw exception. The exception will be thrown, so we're going to end up breaking inside Visual Studio here, saying that the method or operation is not implemented. And then I'm going to continue And what you'll see is then the client, of course, will receive something, which I'm catching. So on the client, we're just going to see the output of the exception, which says here, the server model was unable to process the request. Now this second exception is happening, which is one-way, and we will come back to the client and see the output, which is success. Why? Because the exception is not reported if it's a one-way operation. That makes sense though, right? So I'm going to go ahead and stop running this, and we're going to change it so we can see more information about the exception. So going into the host configuration file again, I'll go ahead and enable include exception details in false. So I've made that true, and we will run this again. Now this time I'm going to run it without debugging just so that it goes faster. No need to break on the exception, and we'll just see the output. So the service is running. The client now has executed. Notice the exception is different here. It says false exception, service model exception details. So the exception that was thrown is a false exception. And we got the message. The method or operation is not implemented. So this is a good thing. Now, there is additional information that was passed back, like stack trace and so forth, so that's the part of the information that we're not happy with sharing necessarily. Furthermore, we don't get to interact with this process, so by default, we're just going to see whatever was in the original exception, and we may need to control that, right? Now, let's go to the service, and let's re-enable that behavior and set this to true. So basically, include exception detail in false is now set to true. And I'm doing it, and I'm coding it against the service. Now, why would I ever do that? Only if I wanted to, possibly if I was doing TCP-only services and I would like exceptions to just look like the original stack trace all the time. But even then, you're going to find you might want to structure better exception handling mechanism like I'm going to be talking about with declared false. So I would argue you probably don't want to use that particular technique. Now, even if we set this to false in the config file, it's still not going to override. It's an XOR operation, so it's still not going to override how the service behaves. So let me go ahead and run this again without debugging. And you'll see that because I have the service behavior, I'm still going to get the proper exception. I've enabled the service behavior to include exception details in false, so the administrator cannot disable that. Yet another reason why that code as it is not particularly useful to you. Now you could create a custom attribute which would, perhaps respect whether we're in debug compilation or not, and then that might be an interesting way to go. And then you might also create some custom code that loads the host and decides whether or not we want to allow administrators to even control that. So there's some interesting things you can do with extensibility, but I'll save that for another day. Now I'm going to go back to the slides. So you've seen now what happens when an exception is thrown, and you've seen what happens when I enable sharing the exception details with the client, that we get a more detailed error. We get the correct error message. So let's continue talking about that. So the thing you want to know about uncaught exceptions is that even if we turn on this behavior that shares uncaught exceptions with the client, we have a bigger problem. And that problem is that the exception that happens that propagates up to the service model, up to the channel layer, is going to tear away the channel with it. And if you have a session like a TCP session or name pipes, or if you have a secure session over HTTP or a reliable session or an application session, so if you're not familiar with sessions in WCF, I will be talking about these things in a few webcasts. The point is that any of those types of sessions, that's going to be taken away with the uncaught exception. So throwing uncaught exceptions is bad if you don't want the session to be killed. And so what that also has a side effect of is that the client proxy may not be useful any further after the exception takes place, because what happens is the proxy at the client thinks it's using this session and the session's gone. So you have to recreate the proxy. So you have to actually be careful of your error handling on the client side as well. So although the debug behavior gives us additional information, it literally rips the channel down and is not a good idea as a general exception handling process. Instead, what we can do is we can throw faults. So the idea would be that when you know an exception could happen at the business layer for a SQL problem, for example, or a configuration error, or something the client sent that was invalid, you should be catching that and converting it to a fault if you'd like to protect the session or the channel. And then that way only unknown exceptions that could have been the result of somebody hacking into the system, let's say, are going to tear down the channel. So let's talk about how we throw faults, okay? So we've talked about the fact that an uncaught exception indicates that there could be a potential problem to the service model. So that's why the service model tears down the channel, because it's assuming if you didn't throw a fault, you didn't know about this problem. So we have three ways that we can get around that by throwing fault exceptions. You can throw a plain old fault exception type, which is a simple way. You can throw a fault exception with a strongly typed details element, which we'll talk about. And you can use the message fault, which I'll explain why you might care about that at some point. So talking about fault exceptions. So this is a very simple way to throw a SOAP fault, okay? What we do is we initialize this fault exception type instead of using a regular CLR exception. And your job is to provide a fault code and a reason. And so remember that I mentioned the different SOAP specs have some default fault codes for client and server errors or sender-receiver errors. And actually by default it goes to a sender error. So if you'd like to make it your fault at the service, then you have to specify the fault code. So for example, this first example shows a new fault exception, and I'm only passing a string. So that's a simple way to provide a sender error in a fault, in a SOAP fault. The new fault exception second example shows supplying a reason but constructing a specific fault reason, which would give me the ability also to set more than one. I could actually create many reasons, and they could have different locale for globalization. And then lastly, fault exception, new reason, and comma, fault code creates sender fault code, which you could also change to create receiver fault code. So what this does is basically these three are equivalent ways to create a fault exception that look identical, okay? And we'll see some other examples. Now the second way that you can throw a fault is to provide a strongly typed details section. So remember, I mentioned earlier that the SOAP fault has a code and a reason, which is a simple string. And then it's got a detail section where you can put a blob of XML that carries more useful information. And so what you can do is provide that useful information as type T, okay? And type T could be, for example, any serializable type or data contract. So that means you could, in theory, use invalid operation exception as shown here, and that would be a CLR exception type that you're opting in to serialize inside the details section. And so what you'll see here is that we're throwing a new fault exception of type invalid operation exception, providing to it an instance of an actual invalid operation exception here, and then providing a reason, which is the short string that we'll see at the client, and then we're providing a fault code, which could be sender or receiver. Okay. Now, one of the values of throwing fault exception T is that we can actually declare those faults, which I'm going to show you in a few sections here, and tell clients, for example, and the service that these are faults. These are types of faults we can send, for example, sender and receiver fault. So instead of throwing operation exception, invalid operation exception, as the detail type, which is a CLR type, for interoperability, since CLR types don't have any meaning to the Java world, for example, it might be better to create a data type called a receiver fault and a sender fault and declare those things as the types of faults we throw. And then here might be an example then of what a receiver fault looks like. So on the server side, something goes wrong. I want the message and the description. And so that would be the details that we store and throw back to the client. We don't want to share any more information than that. We had a problem. Here's the message. Here's the description. Maybe if you had multiple different types of problems, you might have some error codes in here, like an enumeration. And then the sender fault would be another data contract. So notice it is marked with the data contract attribute. And this one will send a message description and a list of elements that failed. So basically, what are the XML elements that the client sent that had a problem in this particular exception? And you can actually come up with all kinds of things that might be useful to your clients. So this is a simple example. Maybe it's a list of XML nodes. Maybe it's something more complicated with other different error codes and things. But the idea being that I have maybe standardized on a few data contracts that are manageable, one for sender, one for receiver, and maybe some other special types that we can throw and that the client can look for. And then the client will somehow know about this metadata so that it can pull out the failed body elements, for example, and look at it and inspect it. Okay, so that's a second way to throw faults. One is a simple fault exception. The second is a fault exception T, which is a strongly typed details element for additional information. And then lastly, there's this thing called a message fault, which is actually a CLR representation of the whole SOAP fault. So that allows you to control things like the node and actor, if you want it, or action, if you wanted to control what that said. And again, you probably most of the time will not care about this, but in the event that you need to specify those things because you are building an intermediary and you are knowledgeable about the SOAP specification, you will need to know how to create a message fault like I'm showing here. So how you do it is you create the fault, passing it the actual fault code, so this is a sender fault code, passing it the reason, so these are things we've already seen, passing it the detail type, which is the invalid operation exception, and then also you can pass these other three parameters. The first is in case you want to provide a custom XML serializer, so that's pretty advanced. The second and third would be actor and node. So again, those are pretty advanced. Those imply that you're familiar with SOAP specifications. So I just want you to know that this is possible. And then I'm going to show you creating a fault in a demo shortly. So fault exception can be created from the message fault by calling fault exception create fault, which is a static function. And you pass it the fault, the message fault, and you pass it the type for the details section, and then you throw it. So this obviously is a little bit extra code. The only reason you'd opt into this mechanism is if you really needed to control those other special SOAP elements. So let me actually show you a demo of doing some work with SOAP faults. So we'll let this show my desktop for a sec. And what I'm going to do is switch over to a different example. And so in this example, what I have right now is a service contract with a good operation and two operations that throw exceptions. One is the one-way. The other is basically the implementation here. The good operation just returns information, and then throw exception and throw exception one-way both throw a not implemented exception. The host has a basic HTTP endpoint. And currently, we are, we could include exception details in faults if we enable the behavior in either place, right? So the default is that we're not including exception details in faults unless I turn on this behavior. I'll leave it on for now because then we'll see the exceptions at the client, and that's fine. Okay, so what I'm going to do is just give this a run first. I'm going to start the host without debugging, and then I'm going to start the client. Okay, so the client will allow us to test, creating a proxy. We're actually using basic HTTP binding at first, which means a couple things. It's SOAP 1.1 format, which we're not going to look at that at the moment. The second thing that means is that there is no session. So I'm going to call the good operation. I'm going to call a throw exception, and you see I get a fault exception with exception detail. And that says that the method or operation is not implemented, and it shows me a stack trace somewhere in there. Then I'm going to call good operation again, and it works. So my proxy's okay. Why? Because there's no session. So even though I killed the channel at the server, that's okay. The channel wasn't maintaining a session that I'm expecting to be there next time I call from the client, because basic HTTP binding does not have session. So I can call the exception on the one-way or on the two-way operation, and we're good. Now what I'm going to do is change that to web service HTTP binding. And web service HTTP binding, by default, actually does have session, because by default it enables something called secure sessions. So here is my WS HTTP binding, and I'm going to change the client to use the same. So let's change the basic HTTP binding to WS HTTP binding. And I'm going to run it again. And while the service is running, I will start the client. Client will load. We'll have an initial proxy that gets created when I load the form, so I'll just work with that first. And so I'm calling the good operation. We expect that to work. I'll call throw exception. I get the fault exception detail. I'll call good operation, and I can't. Communication object faulted. That's because the client proxy made an attempt to call the service, and the service said, I don't have that secure session channel anymore, I'm sorry, and that faulted the client proxy. That faulted the channel. In fact, the proxy knew about that from the response to the exception. Immediately it faulted the client channel as well. That's because it's not one way. So no matter what I do now, I'm going to get a communication object faulted exception, because I can no longer use my proxy until I create a new one. So now I'm going to call the good operation again, see that it works, and then I'm going to call the exception one way. You see, I don't get any exception thrown back, so now the client channel is still okay. But when I call good operation, I'm going to send the original secure session ID, and the server's going to say, sorry, I don't have that anymore, so look what I got, a message security exception. Okay? Most likely because invalid security context token, etc. So what's going to happen now is the next time I call good operation, now my client channel knows that it's faulted, and it says communication object faulted. So the point is that when it's a two-way operation, you know about the fault immediately if you have session, and it will invalidate the client proxy right away. And you can check to see the state of the proxy to see that it's faulted. And then if it's one way, then you don't actually find out until the next call is over. And so what I'm trying to impress on you is that this is kind of a big deal, right? Because we're used to creating proxies and using them indefinitely with web services, for example. And we're not used to having to care if there's a problem. But really, a good citizen at the service would not let a fault throw like this. And instead what we would do is throw a proper fault. So what I'm going to do is get rid of the exception that we're throwing here, and I'm going to assume that we wanted to throw a false exception. So let me do that. So I'm going to show an example of just throwing a simple fault exception first. And then I'm going to show an example of throwing a strongly typed fault exception. So fault exception T, where in this case I'll use a CLR type, not implemented exception. And so this new not implemented exception will have the same string, and then I'll provide a reason, which can be provided in string format, not implemented. Okay? So the detail element is going to now include a fault exception. So let's go ahead and compile this, make sure everybody's happy. And I will run the host without debugging. And we'll run the client again. So because we are throwing a fault specifically, the service model on the server side will say, okay, I'll give this fault back to the client, and it will not fault the channel because it's assuming that you knew this is not a security breach or a problem, and you want to report good information to the client. Nobody really wants to, just kill the server channel abruptly like that. That's only if you don't catch the exception and handle it. So I'm going to throw exception, and I'm going to get the fault exception back, which you see here, the method or option not implemented. And then I'm going to call good operation again, and it works. And I'm on WS HTTP binding. So the same thing for any type of session, TCP, name pipes, reliable sessions, application sessions. I'm going to call the one-way operation, and that will have thrown an exception at the server, but we will never see it because it's basically not being reported. It's a one-way. So notice that I don't have to recreate my proxy. I'm able to call the good operation again and again because of this. So the moral of that story is you should be throwing faults where possible and only allow things you didn't know about or expect to flow up to the client as uncaught exceptions, which will cause the server channel to be terminated. So I'm going to return back to the slides now. And let's talk more about faults. So far I've talked about if you let exceptions propagate, it'll kill the channel. You could, for debugging purposes, at least share this information with clients. I've talked about how you throw faults. I've shown you just now two ways in live demo, and I talked about message fault, which we're going to come back to in the error handler section. So the point being, throw faults, okay? The other thing you should do is declare faults, because then clients know what kind of faults you're throwing, and they will have an easier time of getting at the details element, which is that nice little complex type that you're going to serialize in your faults to make useful information appear. So what's going to happen is we can declare faults, and that's done at the service operation, and what happens is then the faults are actually included in the WSDL document. So your contract will state, for this operation, here are a list of faults that might be thrown. For that operation, here are a list of operations of faults that might be thrown. And so it's actually completely described in the WSDL, so when the client generates a proxy, and by the way, this is interoperable, it will also generate a copy of the fault type. So if you have a data contract which shares useful fault information with clients, they'll get a copy of that data contract. So it gives them strongly typed exceptions and a way to sort of have an intelligent way to handle that. This is done using the fault contract attribute. And so what happens is the fault contract attribute is applied to, again, service operations. And then what you should try to do is in your code throw faults that are declared. And then that way the client will not only not lose their session, but furthermore they will receive a fault that they have information about. So I'm going to actually just show you this with a demonstration. And so I'm going to return to the code here. And I'm going to go to a different example here for a sec. So declared faults. Now, what I have here is a bit more complex of an example because I'm using some real data tiers. For example, I've got a data access layer called counters.dalk, and that's got some code in there to update counters to an actual database. In the service, I actually have a couple of members. So let me just scroll up here to the top of the service. Okay, so the service has a couple of operations. We've got reset counters, set counter 1 and 2 separately, and then get all the counters. And what it's going to do is report to me what is the value of a counter in the database. So I've got a table for 2 different counters. And in terms of functionality, really what's happening is we're just calling down to the data access layer to set the counters as part of a transaction. I'm catching a SQL exception in this particular case in case we have a problem. And in that case, if I catch this SQL exception, I'm throwing a fault. So I'm going to show you what that looks like. Now I'm going to scroll down a little bit further here, and you're going to see that in set counter 1, I'm going to throw an invalid operation exception, or catch an invalid operation exception if there is one, if you try to set the counter to something greater than it should be, and I'm going to throw a different fault. It's going to be a sender fault. So this is my data contracts for fault types. And otherwise, if there's a SQL exception, I would come here. So I'm already throwing faults is the point, okay? And that's fine. I just haven't declared them yet. The other thing I've got here is another potential invalid operation exception in set counter 2. In case you set the counter to over 20, it's invalid. And we'll see all that when I run the code. I just want to give you a glimpse of what's in here before I do that. And then get counters only catches SQL exception. Okay, so downstream code might throw an exception. There could be a problem. And if there is a problem, we are throwing faults indeed. But let's go back to the contract. I haven't declared any faults yet. So let's go to the client. And on the client side, well, actually, I'll just go ahead and run this, and we'll see what happens. So right now, again, I'm not declaring the faults, but I am properly catching exceptions from the business layer and throwing faults in their place that carry useful information so we don't fault the channel. Now I'm going to first set the counter to something valid, like 5. And what we should see is that just works, and the counter values will be updated. So again, it's coming from the database, so I'm actually hitting the database for these calls. And it's updated. Good. Now if I set one of the counters to 12, the first counter doesn't like that number. So what you're going to find is that an exception is being thrown from the data access layer, by the way. And what we've done is caught that exception. Invalid operation exception, counter 2 cannot exceed 10. So because we caught that exception, we're going to go ahead and create a sender fault, which is a class, by the way, that I've described like what I showed in the slides earlier. Sender fault is a bit further down here. It's got a message and a description and an optional list of failed body elements. So it's a data contract, right? Has to be a serializable type. I'm going to create a fault exception and throw it. Now if we didn't time out at the client, which we'll see shortly, then I should get, okay, I'm getting another exception actually at the service because it's trying to do both, so hang on one sec. Okay, so I got the fault exception back. It says counter cannot exceed 10, but I didn't get a fault exception of type sender fault, which is what I'm looking for, something useful so I can dig into the description. So I'm going to go ahead and stop running for a sec, and we're going to actually declare those faults and see what happens. So I'm going to go up to the service contract, and in the service contract what we can do is call, let's say set counter 1 and 2. I'm going to say fault contract, type of sender fault. So I'm basically saying it's possible to send a sender fault and possible to send a receiver fault, which are my data contracts. This is the strongly typed contract, and I'm going to apply those to all the operations. Okay. So all of these operations can throw a sender or receiver fault of sorts, and then what's inside, of course, may depend. Now, what does this do? Well, let's take a look at what happens when I run it. And I'm going to actually browse. While this is loading, I'm going to go get a browser, and I'm going to browse to the metadata and just give you a quick look at that. So once the service is hosted, I'll hit enter on this browser. Okay. So let's browse to the metadata, and I'll show you the WSDL contract and where those faults got declared. So way down at the bottom, scroll up a little bit, and we're going to see sender fault, receiver fault as fault types that can be thrown from this operation get counters, for example. So every operation can have an input message, an output message, and then can also have one or more faults that are declared. And that's how the metadata gets shared to the client. So what's going to happen now is if I go to my client and regenerate the proxy, I will actually know about those declared faults. Right now I haven't done that though, right? So what's going to happen when I call set on the client at this point is it's going to make a call and the exception will come back as a fault indeed, but the client will not know. So I'm going to actually get two exceptions here, right? And the client is not going to know the details of that fault. Why? Because we haven't updated the metadata. Actually, I probably had a different problem there. So I'm going to actually stop running for a sec. And what we will do is refresh the client. So I'm going to need to run the host first. And in this case, I'm going to actually just start the host without debugging. So I'll make that my startup project because we don't need to see that breakpoint anymore. And then the client, what we'll do is refresh the proxy. So this is just going through its thing to regenerate the proxy and the config file. And that means that it's going to get the new WSDL with the fault contracts declared. So let's double check that that got picked up. And here we are. Look at my client now. It's got a sender fault and a receiver fault declared as data contracts. So it works. Now what does that mean to me? Well, let's take a look at the client code. Inside my form, in the location where I call set counters, so here's my transaction scope that sets the two counters in a transaction. So far I'm catching fault exception, but what I could do instead now is I can catch fault exception, sender fault, so SFX, and SFX. And the sender fault is part of client counters localhost. The other thing I can do is catch a strongly typed receiver fault. So that's RFX. And I'll throw a breakpoint in here so we can see which one we got. And recompile the client and run it. Now the only reason I'm able to catch those specific strongly typed faults in this way is because the client-side proxy has declared the same fault contract attribute that we did at the server. Okay, so that's important. So if you don't update your proxy, you don't get strongly typed access. That doesn't mean the message did not contain the details. It did. But the client doesn't know how to process it automatically unless you declare in WCF, unless you declare it the right way. So I'll go ahead and set a counter to a valid value first. And that'll take a sec. But this is just for our sanity check. And then we'll do a setting to 12, let's say, which will throw a fault, and I got a sender fault. You see that? Counter cannot exceed. So my sender fault has a detail element of sender fault. Notice that? The description's empty because I didn't set it, and the message is counter cannot exceed 10. So I'm able to catch strongly typed faults. The moral of the story is that you can inform clients of the types of faults that can be thrown by declaring those faults, and it's better to use data contracts for interoperability instead of using exception types. Okay? So your approaches are, you could use CLR exceptions as the detail element, but again, that's not highly interoperable, so it's not the most desirable way to go. You can define a couple of core data contracts like sender and receiver with codes that mean different things. And I've seen some platforms do that. And some industries, by the way, like insurance, have standards bodies that come up with the way exceptions should be thrown. So that would be an example of, a specification to follow, whatever they say. The other thing you might do is consider having data contracts for every specific type of fault that is part of your application, and make those data contracts and then throw those, and then that way clients don't have to read enumeration codes. Instead, they can just catch different exceptions of fault exception T type, and where T could be file upload, customer data fault, other different types of faults from different areas of the application. And so really just picking one of those two, either the general approach with the sender-receiver fault, or the more specific approach with file upload, customer data type of thing, and other detailed elements. Okay, so now let me just see if there's any good questions here before I move to the next section. What background do you need for learning WCF? Oh yeah, so this is, I think you're going to want to go, well, you could replay the first webcast, or I suppose I could recommend my book because it has labs in it, and it will help you to sort of get past some of the details here, and you can sit offline and go through the labs and read the chapters. So of course I could recommend that. Okay, so no other questions so far, so I'll continue. Now, error handlers. So far we've talked about how to throw faults, now how to declare faults. The other thing you want to think about in your strategy is, what do we do for uncaught exceptions? Shouldn't we notify an administrator about that? And isn't it a bit cumbersome to have to catch every exception from the business layer and then convert that to a fault? Couldn't there be a way to automate that? So the answer is yes, and the first thing you need to understand before you can build a strategy around that is, what is an error handler and how does it work? So WCF gives us a way to do centralized error handling, and in that respect you can report to administrators uncaught exceptions, as well as letting them propagate. You can convert exceptions to faults centrally. You can modify an existing fault to a new type of fault if you'd like to make sure there's a central place that denormalizes faults, let's say. So what you do is you implement this interface called iErrorHandler, and then you configure it. So iErrorHandler has two methods, so it's not very complicated, okay? You implement this interface, and you have two functions. Provide fault is the first function that gets called. And it gets called, of course, after the exception has gone through your operation and you have returned from that, and it's flown up to the service model. And the service model will see that there's an error handler configured and say, okay, do you want to provide a fault for this exception? So what you can do is check to see if there was already a fault, and if there isn't, you could provide one if you are comfortable with converting that exception. So you might have a certain set of exceptions you're okay with converting to faults automatically. And then the other thing is handle error. That's your opportunity to, after the fault has already been more or less returned to the client or the exception, what you're doing here is really saying, hey, I'd like to report details to administrator that a fault or an exception did happen. So how it might look is, handle error could log uncaught exceptions in this way. Handle error receives an exception, and you basically set that to a fault exception, try to cast it to a fault exception, and if it cannot be cast, then it must not be a fault, you see, because that's the base type for all faults. And if it's not a fault, then basically we want to log it. And so I'm showing just writing it to the trace logs here, but obviously this would be to call down to a logging service and set it in the database and so forth, right? Maybe even you could have custom performance counters or WMI events. Provide fault, in this case, doesn't do anything because what we're saying is only uncaught exceptions are going to be logged. And then in terms of anything else, just whatever the service did, the service did. But another way that you could use an error handler is to have it provide a fault. So when provide fault is called, you check to see if the fault is null. And if the fault is null, then, if the fault is null, then that means that we don't have a fault yet. So what we're going to do is check the error type to see what kind of CLR exception it was. And if we're comfortable with that CLR exception being converted to a fault, then we do it. So that implies that in your business layer, you might have a strategy around the types of exceptions that you're okay with reporting a subset of the information, not including the stack trace, let's say, to a client in a more friendly way. Or you might even have custom exceptions that you define downstream in the business layer, and those custom exceptions are the things you convert to false automatically, and perhaps the details element is some useful piece of information about that exception or that exception itself. So this would be useful. Okay, so let me give you a demonstration then quickly of doing an error handler. And so I think that we'll take this in two stages really quickly. I've got an error handler demo that basically right now has counter service, and the counter service already has declared a receiver and sender fault, and the counter service is currently catching exceptions like the SQL exception and like the invalid operation exception. So what I'm going to do is comment that out. We're not going to catch the invalid operation exception anymore in my set counter function. So I'm going to comment both of those out. And instead, what that would do is throw the exception all the way to the client. But what we're going to do instead is I'm going to add an error handler to this service and make sure that it gets installed with the endpoints that I'm exposing. So I'm going to add a new class, and this will be an iErrorHandler, so we'll call this fault error handler.cs. And the fault error handler will have to implement iErrorHandler. And iErrorHandler uses System Service Model Dispatcher, and then I'm going to implement that. And in handle error, what we'll do is just say, hey, I want to log this, console.write line, an exception occurred, and then we'll report that at 0, and then we'll report that. Error dot to string. Now, of course, I would get into some more detailed logging if I was doing this for real. And my demo example is actually got more details in it. So I'm going to say date, time, now. Okay. Now, this is not checking first to see if the error is a fault. So what I would do is what I did in the slides, where I'm saying, fault exception F equals error as fault exception, and we'll go ahead and implement system service model here so that it can work. And then we'll say if F equals null, then we know it's not a fault, and therefore I want to do the console write. Otherwise I don't do anything, right? Now if we handle the exception, then what that means is we return true here because we handled it. Otherwise, I'm going to return false because we didn't handle it. Okay? Okay, so that's that. Now, provide false, what I want to do is I want to check to see if false equals null. Okay? Then basically that means we don't have a fault yet. So if error dot get type equals type of invalid operation exception. So imagine if I had custom exception types downstream, right? I could standardize on a few, or a base type, for example, that I use. Then if I know that it's one of my types, then I'm going to generate a fault for it, right? So message fault, and we'll go ahead and grab that. MF equals new message fault. Message fault dot create fault. And what I'm going to do is provide a fault code and so forth, right? So there's a couple things I can put in here. Now, message fault is actually what I want to supply to the fault, but before I do that, I need to actually also provide the details element. So there's a couple of extra things to do in here, and just since we're tight on time, what I'm going to do is run the complete version that already has all the code done as it should be. So we'll go ahead and just take a look at that. Otherwise, we'll be typing for a while. But you get the idea, right? It was pretty simple to implement the error handler itself. The thing is that there's a couple of extra steps. We have to not only, decide which exceptions to handle and how to provide the faults, but we also have to attach the error handler to the service behaviors. And so those are things I'm going to talk about in my extensibility webcast later, so I'm not going to get into the details of how that actually works at this particular moment. So let's go down to the complete implementation of the error handler here. And what you'll see is the code I already wrote for handle error, so we're good there. And what you'll see is provide fault says if it's the type of exception I'm comfortable with converting, here is the fault exception. I'm going to create an instance of the fault exception strongly typed, and then I'm going to create the fault from it, and then I'm going to create the fault message and set the fault parameter to that resulting fault message. And that's it. Because I'm setting the fault here, I will no longer kill the service channel because we're no longer flowing an exception all the way up the chain. Now, in terms of how to configure this service, like I said, I'll talk about extensibility in my last webcast in this series. I created a custom attribute that implements iService behavior that then attaches to each of the dispatchers, which is the endpoints that are listening for messages. I attached a new error handler. So there's actually an error handlers collection you can add to. And I apply this attribute simply to the service. So all the rest of the code is the same otherwise. And that's that. There's a number of ways you can do that, which is why we'll talk about that when I get to the advanced webcast. But the idea is that this is a complete solution that's already done. I'm going to go ahead and recompile it. And you're going to see that since the error handler is plugged in, even though I'm not catching the invalid operation exception, it will be caught indeed, converted to a fault, and all will be well. So let's go ahead and start without debugging. Oh, and I think I already had an instance of this running, so we're going to have to restart. One moment. Okay, let's start without debugging again. And so the client application is still catching the strongly typed faults the same as I was before, so we don't have to see that again. The WSDL contract includes declarations of the faults. None of that changes. The error handler is simply an insert allowing you to control, do I create a fault or not? Do I log this exception or not? So it's fairly straightforward, right? Okay, now the host is running, so let's go ahead and run the client. And we will see in a second the client screen coming up. It's just loading. And I'll try and send a bad value to the service. The client will get a fault exception back. And the server does log the invalid operation exception. So you see it works, right? Now if there was a different type of exception that we weren't if I didn't, actually, I think it's logging all exceptions, I think, in this case, so that's probably why we're seeing that in here. I think I'm probably missing a step that actually decides whether or not we should be logging that, but you get the idea. I mean, I think you can look at the code separately and play with that. Okay, so to sum that up then, your error handling strategies, your simple approach is throw CLR exceptions from the business layers, catch the exceptions in the service layer and convert them to faults as appropriate and leave the rest uncaught, and those that are uncaught get picked up by an error handler. And you want to log those, because hopefully that'll tell you other exceptions you should be catching. Your second strategy is behind the firewall, you could just throw CLR types from your business layer, declare those same CLR types as faults, convert all CLR exceptions that you care about to strongly typed fault exception T, where T is an actual CLR type. And then, of course, uncaught exceptions will still be logged by your error handler. Now, the cons of this is that now we're declaring CLR types as the strongly typed faults, and those are not interoperable with Java environments, for example. So I think it's better to adopt the data contract approach, which means that we're defining data contracts as exception types, declaring those as false, and then converting those to false only. And in fact, you want to go a layer better, you would create custom exception types that are the data contracts. And then those custom exception types are just automatically converted to false and then thrown up to the client without killing the server channel. Only non-custom exceptions would then be recorded as uncaught exceptions, and those uncaught exceptions would end up being reported to administrators using an error handler. Now, the cons of this is that you need a well-defined strategy. So it's all about the labor that you want to put into error handling, right? But I think that the key is to have some sort of repeatable mechanical process that all developers just do, and this just works. So you can consider those things, and hopefully the sample code and such will help you out with that. Now, to just wrap this up, remember that all the code for my book is on thatindigogirl.com. And so you can just download it. There's a section on error handling and also all the other things that I'll be doing in these webcasts and so forth. And then you can go to my blog or iDesign for additional information. iDesign, we have a lot of advanced things in there, including some error handling capabilities that my colleague Yuval has done. So you might want to take a look at some of those examples as well. And with that, I'll go to the questions and see if there's any in the queue. And let Sarah take the floor back.
All right, thanks, Michelle. And as Michelle mentioned, we're going to be doing the final question and answer session real quick since we're running out of time. So if you have any last-minute questions, go ahead and type those in now, and we'll be answering them verbally. And then also, we're going to be doing a survey for you. So I'm going to put the survey up in just a second. Fill out the survey. Should take about a minute, minute and a half to give us some feedback so that we can create better webcasts for you. And to view a replay of today's live event or to register for upcoming webcasts, please visit microsoft.com/webcast. Now is also a great time to go ahead and print a copy of today's webcast PowerPoint by simply clicking on File and Print to PDF. So Michelle, I'll hand it back to you to answer those couple of questions in the queue.
Okay, thanks, Sarah. There's a question saying, is there a way to set the fault type attribute, so the fault contract attribute, at the service level versus the service method level? So there used to be a way to do that declaratively, and there is no longer a way to do that declaratively. It was removed, and I think part of that is that it's actually explicit in WSDL, right? So in WSDL, you have to declare the fault at every operation as well. So at the moment, that's no longer available. Somebody's asking if they can get the labs too. So I mentioned that the download on my site has all the code samples from my book. That does include the labs and the completed labs, but it doesn't have the instructions for how to do the lab. So that would be, you get that with the book basically, right? So, but there's tons of samples separate from the labs, so you can choose either or. Those are the only questions I see in the queue right now. So if any more come in, I'll be here for a bit, but thanks everybody for participating. And in a week, we're going to do another one of these. So stay tuned for that. Remember to go to dasblonde.net to find out the list of all 15 of these webcasts.
All right. Thanks again, Michelle, for a great webcast, and thanks to everyone for joining in. Happy Friday, and have a great weekend. That concludes the audio portion of this webcast.